Hi, I'm Adam. Welcome back to Godot Game Lab. This video is going to be a pretty different one, a weird episode, so to say. As you can see, we have no demo here, but I have the project open. So today we have to investigate a pretty strange bug with our game and hopefully learn a lot along the way. First of all, let's go to the script tab and add some testing code so I can show you what I mean. Press Ctrl-Alt-O and search for unitgrid.gd. In this script, if we scroll all the way up, we have our ready callback, and between the ready callback and the add unit method, we'll override the input callback as well. And the first iteration will be pretty simple. When we press UI accept, which is the enter key by default, we'll print our units dictionary containing all the units currently registered inside a unit grid. Okay, so what does that even do? Let's go back to 2D view and run the game with F5 or clicking on this button. And first of all, let's move these units to the bench. Now, if we press the enter key, we'll have two dictionaries that are printed out, and the first one will be the bench because we have two play areas. The first one will be the bench, and it's correct because at the first three coordinates 0, 0, 1, 0, and 2, 0, we have three unit instances, and all the other ones with the game area included are completely empty with null values. So far, so good. If we go to the remote scene tree and take a look at our bench unit grid, you'll see that all three of these units are instanced under the bench unit grid or moved under the bench unit grid as they're supposed to be. Okay, so where's the bug? Let me show you one thing we can do with the units. So we can sell them, right? So as long as I start dragging this unit and click on sell, you'll see the unit will be deleted from the scene tree. So it's no longer there. And when I press enter again, you'll see that the dictionary changes. So at 0, 0, we have a unit instance. At 1, 0, we have something here called FreedObject. And at 2, 0, we also have a unit instance. Okay, so that's weird. What is that FreedObject doing there? What happens when we try to buy a new unit? So the new unit should be put into this place, right? It should be spawned right here because we have an empty slot there. So if I click on Robin from the shop, okay, so then we have a new area, 2D, the unit instance under the bench unit grid. And if I clear the console and press enter again inside the game, then everything seems fine again, right? We have a unit reference here at 0, 0, a newly instanced unit at 1, 0, and our unit 3 at 2, 0. Everything works fine again. If we go back to the game window, another way to sell units is to hover over them like this one and press S on the keyboard to quick sell them. Again, the unit gets deleted from the unit grid. And if I press enter, you'll see the same thing happens. So we have a unit instance at 0, 0. We have the newly instanced one from the spawner at 1, 0. And again, we have a freed object at 2, 0. At first glance, this might not seem like a bug. So when does it become a bug, and what is this free object doing here? Let's investigate. So if we stop the game, clear the output, and go back to the script tab, let's add some extra lines of code here. It's not much, but we added another print statement or two of them. We have some lines to sort of just make it easier to identify things. And then we print the return value of this getAllUnits method. Let's press and hold Control and click on it to see what it does. And you'll see when we grab all the units inside the play area, we return an array of units, and we just loop through the values of the dictionary we just printed. And if we have a unit which is not null, which is a valid value, then we append that unit instance to this array and return it, right? Pretty straightforward stuff. And we call this method inside our input when we press enter on the keyboard. So let's run the game again with F5, move the units to the bench so they get registered there. And what happens if I hover over Robin and press S on my keyboard? Okay, the gold gets added, so selling works, but if I press enter now we have an error message. What happens here? If we go to the output tab, you'll see that we still printed the dictionary just like we have before. We have the area 2D, we have the freed object, and then we have unit 3. So what is going on here? If we go back to the debugger, we can trace back the stack, what was the order of execution here, and from the input callback, we call this getAllUnits and want to print the return value of this method. If we click on getAllUnits, so this is the line of code where it fails, this array.append method. And what happens here is if you take a look at the unit array, the one we want to build, if I click on this, you'll see that this array already has one element. Why is that the case? If we go back to the output, you'll see that the first unit that actually occupies our bench grid is a valid unit instance. And when we try to append the second one, that's when the code fails. Why? Well, because this object no longer exists. So that's when this FreedObject thing we have becomes a problem. And it might seem like things kind of worked, but this would cause a lot of problems down the line. Because if you think about it, there can be a lot of cases in the game when we want to get all the units that are currently sitting inside a play area. And whenever we have a unit that was deleted for whatever reason and we still have that hanging reference, then our code becomes buggy. So we somehow need to fix this. I just wanted to present you the problem first before actually jumping into the solution. Also, at this point, it might be super confusing. What is that FreedObject? Why does it happen? And what can we do about it? Let's investigate what it is first. So imagine a scenario like this. We have our unit grid, which is a dictionary where we have the keys, which will be the tile coordinates, and the values, which will be references to units. So what does a reference mean? When we saw the output console messages, you saw these names and numbers which identify a specific instance of a unit. So to make things easier to imagine, I just displayed the values here. So we have a bench like this where 3 tiles are occupied, the first one, the third one, and the sixth one. So these are the references we have to 3 different unit instances, right? So we can sell units in 2 different ways. And both of these selling mechanics will essentially delete those unit instances, right? So one method is to start dragging the unit. So what we do is we grab the unit with the mouse, we move it to the sell portal, release it, and then the unit instance gets deleted with Q3. The thing is, we still have that hanging reference to unit 1, but what does it refer to? Well, basically nothing, because that's an object that doesn't really exist anymore since we deleted it with Q3, right? So in cases like this, when we want to have a manual table or a lookup table, a dictionary like this, where the coordinates are associated with unique instances of a scene, it is our responsibility as developers to make sure that we only have references that are actually valid inside the game. And this is no longer a valid reference because just by releasing the mouse, at this point it's still a valid reference because the unit instance exists in the game. But as soon as we let go of the mouse, in the first available frame, the unit will be deleted. So this unit 1 reference we have as a value inside our dictionary is no longer valid, right? Same thing when we use the quick sell action. We hover over the unit, press the S key on the keyboard, the unit will be sold, it will be deleted, and that reference will immediately become invalid. So this is what it means when it prints out FreedObject. It means that we had a unit reference which was valid, and this was stored as a value inside our dictionary, but it refers to something that was already freed, meaning it was deleted. Right? Hopefully that helps you a bit to understand what's going on here and why we have a problem in the first place. Now that we talked about this, let's see how we can actually fix it. And just before fixing the problem, let me show you a couple useful or interesting resources in this topic. I had to do the research myself because when I was doing the reference project, I kept banging my head against the wall to find an elegant and good solution to this problem. So with a quick search, you might get this article from the Godot forums where another developer encounter the same problem. You can see this FreedObject output message in the console. So interestingly enough, there are a couple cool answers, and I see that the OP linked a very cool video for this forum thread. But let's see what the best answer says. And the key part of this answer is the last sentence. So when the object is gone, it's your responsibility to dispose of any references to it your code still may hold, either as array elements or otherwise. So in our case, this means that we actually have to delete this reference from the dictionary value when the object gets deleted from the scene tree, right? Because that would solve our problem. So if we could somehow recognize when an object is being deleted, we can say that, okay, if this sits anywhere inside our dictionary, then we can delete it. Pretty straightforward stuff, right? And to do this, we need to have a bit of a deeper understanding of how nodes work inside Godot. Fortunately for us, there are a lot of cool documentation pages that might help. All of these will be linked in the description. So the first documentation page, which is relevant for us, is regarding the scene tree. So if we scroll all the way down, you'll see there are a lot of interesting bits and pieces here. I definitely recommend you checking it out. But this is the relevant part. It sort of describes the procedure of how nodes enter the scene tree. So you'll see this describes sort of the life cycle of a node inside the scene tree. It gets loaded somehow. Then we add a root node to the scene, which needs to exist. All these subsequently added nodes will receive the enter tree notification, then the ready. And then when a scene is, or part of it, is removed, they receive the exit scene notification, which has the exit tree callback in GDScript. Okay, now that's a good sign. So we do have some sort of a notification or a signal emitted when a scene or a part of a scene or a node exits the scene tree. So what are these notifications? Well, we have another documentation page for Godot notifications. There are actually a lot of notifications you can tap into, but just like the docu page says, some of these notifications are useful, so they have their own override scripts as well. For example, we have ready, enter tree, exit tree, process, physics process, and draw. Most of you probably already knew. So we have these notifications we can rely on, and they are very detailed right here, how they work, how the export value assignment works, and a lot of stuff. But we are actually interested in none of these for our problem because we want to handle exiting the scene tree. So if we go to the node classes documentation page, it's a really long page where you have access to all the methods and members that are available for every node. But what we are really interested is exit tree here. So it says that it's called when the node is about to leave the scene tree upon freeing, scene changing, or calling remove child in a script. If the node has children, its exit tree callback will be called last. After all its children have left the tree. And what's also cool about this is that it says we have two signals, tree exiting and the tree exited, when the node has already left the active scene tree. Okay, so we do have a signal we can use. That's promising, right? Let's go back to the project then and try to fix this first. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. Now having the project open again, the code itself will be pretty simple, I think. We just needed the whole explanation so you can understand what's going on here. For now, we can get rid of this input callback because we needed this to sort of just understand what the problem is in the first place. We can delete this. And just to make sure you see that, let's go back to 2D view for a second. And if we select any node in the scene tree, for example, the tile highlighter will be a good example because it's a simple node, right? If we go to node and signals, you'll see all these signals are connected to those notifications. And we do have one called tree exited, which is emitted after the node exits the tree and is no longer active. And we have the tree exiting, which is emitted just before when you exit the scene tree. Okay. So we can use tree exited, we can wait for the unit to be completely removed from the scene tree. That's fine, we can just delete that hanging reference after that happens. So we can use this with the units as well, because if I click on the unit, you'll see we have much more signals, but all nodes are basically derived from the node class. So we do have tree exited and tree exiting here too. So now if we go back to the script tab, we need to add a couple lines of code. First of all, when we add the unit to the unit grid, it can only happen by calling this add unit method, right? This is when we sort of register inside the dictionary this unit reference. So what we can do is we can say that the unit's tree exited signal should be connected to our own callback method. And since we do have access to both the unit instance and the tile coordinate where we want to add the unit, we can bind those as parameters to our own callback method, which we are yet to implement, and we can make sure that the unit grid will be responsible for clearing up those hanging references. But just adding it like this is problematic because we can swap units between the different play areas. And this means that when I drag the unit from the bench to the game area, the game area's add unit method will be called, and then we connect to that tree exited signal 2 times from the bench and from the game area as well. And we don't really want that. It's enough to handle for that specific play area this tree exited callback where the unit was before being deleted. And this is actually pretty easy to do. What we do is we scroll down to the remove unit method. So when we remove a unit from a unit grid, we just say that we can disconnect the unit's tree exited signal from our callback method, right? This way, when we remove the unit from the bench and add it to the game area, this signal will be disconnected from the bench, but for the game area, we will connect again. And with that, we make sure that to each and every unit instance in the game, there will be exactly one connection to this callback method. And the final thing to do is to actually create that callback method. So if we scroll all the way down, we have the get all units method, which is the last one. And then we can just do something like this. So we say that when this unit exits the tree, with the bind, we get both the tile coordinates for the unit and the unit reference. And we just need to say that at this coordinate in the dictionary, we want to use specifically a null value instead of having that reference to the freed object. Right? And when this happens, we can actually emit the grid changed signal too, because, well, if we delete a unit, the grid definitely changes. So if we save the script with Control S, this should fix our problem. And now that I think about it, deleting the test code wasn't the best idea, because how else should we test if this works or not? So let's just scroll back up and re-add that code for the input callback so we can test if it works or not. Because if you remember, this print statement crashed the game before. So let's save the whole thing with Control S and test the game by clicking on the play button. So if I drag the units to the bench and press enter, we already have a problem. All of these coordinates we have null. And that is super weird, isn't it? So if I drag them around, oh, what happens here? We have errors popping up. Signal tree exited is already connected to given callable. Oh my God, what's going on here? We just broke the game. So it doesn't even work anymore. We have error messages. Now if I press enter, I do have some references to units, but not all of them. What the heck is going on here? That should have fixed our problems, right? And that's exactly what I said when I was trying to fix that problem in my reference project. But the cool thing about Godot is that it's open source, so I can always look under the hood and see what's going on here. And what I found out is that when we do the dragging, we actually reparent the units, right? We call this reparent method for the node to set a new parent to it. And if we go back to the script tab, press Ctrl-Shift-F and search for reparent, you'll find that inside the unit mover script, when we move the unit, we will reparent it to its new unit grid. And that's exactly what happens. So if I play the game and go to the remote scene tree and drag the units over here, you'll see this unit will be reparented to the bench unit grid. But if I drag this unit over the arena unit grid, that's where it belongs now. So this is when we call this reparent method. And that's the culprit, actually. Took me a while to figure out, but let me show you how I did it. So this is the node classes C++ code for Godot. It's pretty long. It has 4,000 lines of text, but it's not that bad, I promise. So if I press Ctrl F and search for reparent, you'll see that we have this reparent method here. And we have a bunch of code, yes, but what's important is this part. So how it works is it removes the child from the current parent and then adds the child back to its new parent. Okay, but what happens when we remove a child from the scene tree? So if we press Ctrl F again and search for remove underscore child and take a look at this method, scroll all the way down, we have a notification for unparented. Okay, sure. But that's the key part here. So if the child was inside the scene tree, remove child will actually emit the exit tree signal. And you might already guess that this causes a lot of problems. If we go back to the project, go back to our unit grid script and scroll all the way down to our new callback method. And just by using a print statement here and printing something like tree exited or unit, save the script and run the game again. Drag the unit around. Did you see that? So whenever we drag these units and let go of the mouse, the tree exited signal will be emitted when they are reparented, because they will be removed as a child from their old parent, which temporarily removes them from the scene tree before we add them back to a new parent. And that's a problem to us because we only want this callback method to be called when we actually exited the scene tree for the reason of being deleted from the whole game, right? We only want this to happen when the unit is deleted with Q-free, not when the unit is temporarily leaving the scene tree for reparentation. Does that make sense? But that's a pretty easy fix, actually, and this is the last step we need to take. So instead of this print statement, what we can say is that we have this method called isQueued4Deletion, which returns true if the Q-free was called for that node and false otherwise. So by moving these statements inside this if check, we'll make sure that we only delete this unit from the dictionary by hand when the unit actually leaves the scene tree for the purpose of being deleted. This safeguards us from accidentally calling this when we reparent a unit inside the scene tree. So when we save this with Ctrl S, we should be good to go. If we play the game again, drag the units to their place, press enter, you'll see we no longer have these weird null values. The first 3 tiles will be occupied by unit instances, and after these dashes, the getAllUnits method works now. It doesn't crash. Okay, cool. So let's see how it performs when we actually do sell units. So let's sell Robin by dragging him to the portal, go back to the console, clear it, go back to the game and press enter. See that? It no longer crashes. We have this reference to the first unit, and at 1,0 we no longer have this FreedObject reference, we have null, which is perfect. It doesn't cause a crash, and getAllUnits will return an array of 2 unit instances instead of crashing out. Just to make sure, we can sell another unit by quick selling. So hover over the unit, press S, press enter again. And with this last one, we should only have one remaining unit at 0, 0. At 1, 0 and 2, 0, it will be null. And the getAllUnits method will return an array of 1. Awesome. So I really like this solution because we could have handled this inside the cell portal. So if we press Ctrl-Alt-O and search for cell portal, this is where we sell the unit, right? This is where we queue free, we delete the unit, and we could have done something like emitting a signal or having an export variable reference to the unit grid. But that doesn't really make sense because it's not the cell portal's responsibility, right? The cell portal has nothing to do with keeping up freed references and handling stuff like that. This is the unit grid's responsibility. So by tapping into this tree exited signal, we kept the responsibility within the unit grid class, which I think is a pretty elegant solution. And we solved this problem by adding basically like 6 or 7 lines of new code. We have a connection to the signal when we add a unit, we disconnect when the unit gets removed from a unit grid. And inside that callback method, we check if this tree exited signal was emitted because the unit will be deleted from the game. And if that's the case, we make sure that we don't have this lingering freed instance reference and emit the grid changed signal. Pretty awesome, right? So hopefully this video was informative and you learned something about how Godot handles nodes and references. The one final thing we want to do is now we can actually get rid of this testing code. We no longer need this. Save the script with Ctrl S and we can move on. And the reason why we did this now is because we'll do unit combination next. So we'll take a look at how you can combine units together when you have 3 or more matches into higher tier units. And when we do that, we want to delete units after they were combined into one higher tier one. So we could have run into some pretty nasty bugs if we didn't fix this before. So I figured this deserves its own episode before we move on. So that's it for this one, and I'll see you in the next one. Bye-bye.